We're going to be looking at 4.4, the Desmos activity today. If you're watching this, maybe you were absent when we did this in class, or you just need another refresher as to how some of these problems worked. Again, this is 4.6, the Desmos activity. I hope you're having a great day. The goal is to solve linear inequalities and represent the solution. So this section should feel as if it's a review of sorts, and that's on purpose because this is the final section of Module 4. Congrats for getting there. Let me applaud you. Let's dive into some of these problems. You might be asked to read them once, read them again, then maybe think out how it's going to be put together. So take a moment, pause the video, read through this, and we'll chat in a second. Joaquin, maybe Joaquin Phoenix, plays Joker. And Serena, I don't know, Serena, maybe Serena Williams, are looking at the problem 3x plus 1 greater than 0. Serena says that the inequality is always true because multiplying a number by 3 and then adding it 1 to it makes the number greater than 0. Is she right? Explain why or why not. Well, let's imagine if we were going to solve this going against the steps that are mentioned here, we're subtracting 1, or then taking 3x is greater than -1, we divide by 3. This is claiming that x is greater than -1/3. So any number that's greater than -1/3 should work. So you have some options here. So if x is 0, that's true. That's going to say that 1 is greater than 0. So that's just one example that we have there. But Serena's saying that it's always true. So maybe let's think, can we find a number that would make this false? What do you think? Find a number that makes this false? Well, we could pick any number that doesn't satisfy this, so something that's less than -1/3. So let's try x is -1. Here we got 3, we'd multiply it with -1, we'd add on 1, this is claiming it's greater than 0, 3 times -1 is -3, -3 and 1 gets you -2, and then this is saying -2 is greater than 0, which is false. So there are options. This is incorrect. It's not always true. So is Serena correct? No. And reason being, if we substitute x for a number that is less than -1/3, it produces a false statement. There you go. That's what you need to know. Take a moment, read through this problem. Joaquin and Serena at it again. Let's read through this together. We have the word problem Joaquin and Serena working on says 4 greater than x. Joaquin says that they should write 4 greater than x. Serena says they should write 4 plus x. Explain who is correct and why. Well, again, the wording is a big deal here. So let's just rewrite this. So 4 greater than x. What do you think? Who's right? Well, we might have to dive a little bit further into this. So over here, let's write this 4, and this will be Joaquin's interpretation. So this is saying something. Let's look deeper. So this is saying that 4 is greater than x. But if we look over here and sketch out Serena's situation, Serena has that 4 plus x. And there are a bunch of ways that we can interpret this. We could think of this as x plus 4, 4 plus x. There are a bunch of ways that you could interpret this. But I think it comes down to the wording, because if we have 4 is greater than x, that matches that, but this is missing the is. Whereas over here, 4 greater than x could have been written as this. for greater than x, or for, it comes down to the is. I mean, it really comes down to that. So for greater than x, I'm going to go ahead and say that Serena's right, but I think it comes down to the is. That might be the main thing to focus on. Because generally for greater than x is stated as for is greater than x. So it kind of depends on the problem situation, not just the keywords. So maybe if this was comparing something that might have a different context to it, I hope that helps. Joaquin at it again is thinking hard about equations and inequalities and comes up with this idea: if 45 plus 47 equals t, then t equals 45 plus 47, okay? So if 45 plus 47 is less than t, then t is less than 45 plus 47. Is he right? What do you think? I'm going to break this down into two phases. So the first one, 45 and 47 equals t. Okay, that makes sense because we're adding the same terms. Like these are both positive. So even if we were rearranging this and saying we want t to come first and then 45 and then 47, this works and this works. Okay, so far this is true. But if, and this is if, so if 45 plus 47 is less than t, then they're saying that t should be less than 45 plus 47. Well, that doesn't quite work. Think about this. This is saying that t is greater than all this, whereas over here, t is less than that. So it's kind of putting it in a weird position where they're claiming t is greater than all this, but also t is less than all that. And this is rather conflicting. And I'm going to make a note of this. This is conflicting. They're not including equal to. So is he right? No. Because it's kind of bounding it in between these two values, but it's not going to work because you don't have equals involved. So equal sign is not involved. Doesn't work. The same way that the addition version works. There you go. Boom. Take a moment, pause, read this. Serena's checking her work with Joaquin, finds that they disagree on a problem. Here's what Serena wrote: 3x plus 3 is less than or equal to negative 2x plus 5. What step do you think went on right here? What step? If you had to put this into words, we've practiced this before. What's happening right here? What do you think happened? Well, it looks as if they took the 3 to the other side. So this was subtracting 3 to both sides. It's fine. That's a safe move. And then what do you think they did from line 2 to line 3? It looks as if they were trying to move the 2x to the other side. However, what operation did they use? Tried to subtract 2x, but they should have added 2x because it's a negative 2x there. So is she right? Nope. Let's give this a shout. Serena did a great job with the first step. However, when trying to combine like terms, she accidentally adds 2x to the, or sorry, subtracts 2x on the left side. She should have added and divided by 5 if you're so curious. helps. Let's keep this going. Take a moment, pause, read through this. We'll touch base in a second. I'm just going to go to town on this. I'll explain my steps when I'm all done, but I know that I see parentheses here, so I'm going to try and get rid of those. -4 times 3m gets you -12m. -4 to -1 gets you +4. This is less than or equal to 2m plus 6. And then I would call this distribution on both sides. I'll put my steps on the right. So what am I going to do here? I'm going to move my m terms. Well, which side do you think the m term should go to? Well, I see more positive m terms over on the right. So I'm going to move m terms to the right. So m terms moving to the right, which means that constants are going to the left. I see that if I want to move this -12m, I'll have to use addition here and here. Then I would move constants to the left, deducting 6 here, deducting 6 here. This cancels. 4 minus 6 gets you -2. This is greater than or equal to 14m. Take it further, divide by 14. 14 cancels. So this is division, property of inequalities. Doing that to both sides. M is left here. Do I have to switch the sign? What do you think? Nope. You divided by +14, so no need to switch. This is claiming m is less than or equal to -1/7. So your answer could look like this or this. Either one works. Got two options there. And then what I did down here was just simplify the fraction if you're so curious. And of course, I'm noticing that 2 is a common factor for the top and the bottom. So if I cancel the 2's, retain the negative sign, -1/7. There you go. Joaquin and Serena know that some equations are true for any value of the variable, and some equations are never true, no matter what value is chosen for the variable. They are wondering about inequalities. What could you tell them about the following inequalities? Do they have solutions? What are they? How would you graph their solutions on a number line? Well, let's just try to solve them. I think that's the easiest way to do it. We have 4x plus 6 is greater than or equal to 6 plus 4x. Move our x terms to the left or to the right, I guess you'll see here. Then try to move 6's here. You get cancellation here, and here, and here, and here. So this is actually going to say 0 is less than or equal to 0. So this means that x can be any number. So x can be any number. Because if you look closely, the equal sign means that the left side can equal the right side. And since they're both +4x, both +6, it can be any number on a number line. So you could draw the number line like this. You got 0 in the middle, say 10's over here, -10's down here. All of your solutions are going to work. So everything. And maybe even to really amplify it, show arrows going to the left and to the right. Hope that helps. So you don't have one set point on this example here. I hope that helps. The literal inequality, ax plus b is greater than c, to solve for x. Joaquin says that he will solve it just like an equation. Serena says that he needs to be careful because if a is a negative number, the solution will be different. What do you say? What are the solutions of the inequality? All right, well, let's just try it. Because if we have ax plus b, this is greater than c. Deducting b on both sides, that's not a problem. You're then left with AX is greater than C minus B. If you're solving for X, you divide by A. So this is interesting. Okay, so let's think about this. So if we're dividing by a positive A, we're just going to say X is greater than C minus B, and all of that is over A. And again, this is if A is positive in this example. Then that would be your answer. But let's imagine that we had negative AX greater than C minus B. If we divided both sides by negative A, that's going to switch things up because X is now less than C minus B over negative A. So notice the difference. This is if A is negative. It makes sense to me. I think the solutions for the inequality are slightly different. If A is negative, we're looking for X values less than this fraction because this whole fraction is now negative. Whereas if A is positive, we're looking for X values greater than all of this. Hope that helps. If you have any questions, holler, let me know, say something. Thanks for watching.